Problem number 4. We're asked to find the missing digits in this number 1, 2, blank, 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 6, so that the number itself is equal to the product of 3 consecutive numbers. And we're also asked to find what are those 3 consecutive numbers. So let's write this out. I'm going to put some commas in here. 1, 2, blank, 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 6. We have 4 blanks. So if I put commas in here, you can see that it's over 1,000,000. Alright? And it's the product of 3 consecutive numbers. Alright? So let's try and narrow down the possibilities for these 3 consecutive numbers. What could they be? Well, when you're multiplying 3 consecutive numbers, that's going to be pretty close to a cube. Okay, that's good. So if I look at 100 cubed, that's equal to 1,000,000, right? And I can also look at like 110 cubed. That's not too hard. Essentially it's 11 times 10 cubed, which is I can take 11 times 11, that's 121 times 11, and I end up getting let's see, 121 and 121 0, oops, sorry, let's see, I reset 0 because I'm trying to add these. So let's see, 1 3 3 1. Okay, so 11 cubed is 1 3 3 1, and then we're going to have times 10 cubed, which is going to add 3 zeros to it. Okay, so 110 cubed is too big. 100 cubed is too small. So our 3 consecutive numbers are probably somewhere between 100 and 110. So that narrows it down. The other thing that we're given is the units digit, which is a key piece of information. And so if we look at, we're going to have like, we could have 101 times 102 times 103. Now, if I take, you can just look at the units digit to determine what the units digit of that product will be. So if I take 1 times 2 times 3, that's equal to 6. So that would give us the right units digit. Let's look at the other possibilities. 2 times 3 times 4. Now, I can see this is like 12 times 2, so that's going to end in a 4. That's not going to give us the right thing. So 3 times 4 times 5, now that's 20 times 3, that's going to end in a 0, that's not going to work. 4 times 5 times 6, again we have 20 times 6, it's going to end in a 0. 5 times 6 times 7, okay, we have that 5 in there, so anytime we have a 5 with an even number, we're going to get something ending in 0, so that's not going to work either. Let's keep looking here. 6 times 7 times 8. Alright, this one we're going to get 42 times 8. It's going to end in a 6. Alright, so it's something 6. I don't have to calculate the whole thing out. At least not yet. I just want to narrow down which ones of these units digits will end in a 6. And then, let's see, I think we just have one more. So 7 times 8 times 9. Now, that's going to be 56 times 9, and that's going to end in a 4. So that is not going to work, right? So we have 2 possibilities. We have the 1, 2, 3 possibility, or we have the 6, 7, 8 possibility. Okay, so we're looking at either 101 times 102 times 103, or we're looking at 106 times 107 times 108. So that'll give us numbers that are in the right range, the 1,000,000s range, and they're going to have the right units digit. Now my gut says that, because this is 1,200,000 and something, that's actually closer to 110 than it is to 100 cubed. Okay, so my guess is that, if I just had to guess and move on, I would guess this one. But we can actually calculate those out. I'm not going to take the time to show you the details of the multiplication. I'm sure you can do multiplication, but So if we multiply this out, we get 1,061,106, which obviously that's not going to work because the 100,000ths place should be a 2. Okay, so now let's check this one, and when we multiply that out, we get 1,224,936. So this one fits the criteria up here as far as the digits go, and it's the product of 3 consecutive numbers. And I probably could have said, integers or something. You probably guessed that. So the answer to this problem is that the 3 consecutive integers are 106, 107, and 108, and the number is 1,224,936.